You are welcome back to this channel. I know there is a reason you clicked on this particular video. You have some particular expectations. I expect that if you are here, it means you are taking algebra this particular semester, and so transitioning from doing basic arithmetic calculations to algebra may be very daunting. I've taught online for a couple of years, and one of the most sought after course online is algebra for some reason. Okay, so today I'm going to give you an insight on how to transition from your basic arithmetic calculations, that knowledge we have, how to transform them into an algebraic knowledge that would help step up your fundamentals even as you take algebra for this particular semester. All right, rule number 1. In algebra, it is very likely you are going to represent numbers as letters. Kindly note this. That's the first and one of the most important rules that I can give you. So let's look, for example, 2 plus 3 is equal to 5. Right? This is basic arithmetic. You add 2 plus 3, that gives you 5. In algebra, you most likely will see something as this: A plus B is equal to 5. Now, in one sense, these two equations are comparable in many ways, but one is purely algebra and the other is not. You understand? Now, these alphabets that we use are called variables. If letters are representing numbers, it means that just as you can multiply 2 by 2, you can always multiply x by y. You can multiply 2 by x. You can multiply 10 by a. You can do all of these operations that you do arithmetically on numbers. So let's look at it. Let's look at how we can interchange numbers in addition. So let's look at it. Here we're going to talk about something we refer to as addend. And then addends are numbers that are being added. So if I have 3 plus 5 plus 8, and that is equal to 16, these are referred to as addends. In algebra, you're going to have the same thing: A plus B plus C, and that is equal to 16. Again, it's the same concept. We have our addends. In the same way, these are my addends. Okay, so what is the difference between these two? Here we have what we refer to as numerical addends, and here we have what we refer to as literal addends. So these are numbers, these are alphabets, and we are using the alphabet as numbers, as variables, performing arithmetic calculations. But here you want to transition into algebra, and you have to know how to incorporate letters into the basic knowledge you have already. Okay, so here I'm mentioning numerical addends, literal addends in algebra, right? And so usually another thing that we have to take note of is interchanging numbers in multiplication. Okay, so let's look at it. We mentioned addend when we were adding. Okay, here we are going to talk about what we call factors. Whenever we are talking about multiplication, we talk about factors. When we are talking about addition, we mention addend, right? So look at it. For instance, in your basic arithmetic knowledge, you knew that 3 times 5 is equal to 15. Now we would say that these numbers 3 and then 5, they are factors, and the resulting value of this multiplication is called product. Okay, this is called product. And so factors are numbers that are being multiplied, and the product is the result or is the answer of that multiplication. Okay, in algebra you are going to see something as a times b is equal to, let's say, 15, or you can have, let's say, x times y is equal to pq. You understand? In this case, we have to understand that a here and then b are our factors. 15 is the product. If you go all out, x is our factor, y is a factor, pq is our product. You understand? So every principle, every fundamental principle that you know regarding arithmetic also add here. We talk about other things that are very important during this transition. Okay, now here we want to take note also that, look at it, 2 times 3 times 4 is the same as 3 times 4 times 2, because 2 times 3 will give you 6, 6 times 4 will give you 24, and that is the same as 3 times 4 is 12, 12 times 2 is also gives you 24. Now this is the same because of the property we call the commutative property, right? Property of multiplication, right? Now in algebra it's the same thing. If I have a times b times c, this basically is the same as b times c times a, but again we have our preferred order. Especially when you have numbers like this multiplying, we usually want to arrange our numbers in alphabetical order. Can you take note of that? It's another thing that is very important in arithmetic is order of operations. So fundamentally, when you have numbers that are multiplying or adding, there is a particular order that you have to multiply it. So in arithmetic, we're going to go by what we refer to as the PEM. Now, according to the Pemdas Rule, multiplication and division they have the same order of precedence. So when you have multiplication and division occurring at the same time, you solve your equation from left to right. The one that comes first is solved first, and the same thing happens to addition and subtraction. But this is parenthesis. P is for parenthesis, E is for exponentiation, right? Let's say exponentials. M is for multiplication, D is for division, A addition, and then S is subtraction. Okay, now in algebra it's the same thing. The rule does not change. We'll still be working with the Pemdas Rule. So for instance, if I have 3 plus, let's say, 2, this is 5, and that will give you 10. In the same way, if I have 2a plus 3a, it's going to be 5a, which when you multiply will wind up as 10a squared. Maybe you don't know this yet, but just as a form of demonstration to you. Okay, so all of these things do not change. So your basic knowledge in arithmetic is still relevant.